All right, so we've gone over three types of tissue. We've gone over epithelial, muscle, and nervous. So our fourth type is connective tissue. What you're going to see with connective tissue is that it's very diverse, and by diverse I mean um, one connective tissue can look completely different and have a completely different function than another type. So a couple real quick examples. You have bones, you have blood, you have fat. All of those are not technically, all of those are connective tissues, but they're really going to have completely different functions and completely different makeup. So let's get into this connective tissue stuff. So first of all, you see there that first sentence, the most abundant tissue type by weight. Large portion of our body weight is made up of connective tissue. And you're going to see that as you go through, it'll make sense. Like, okay, now I get why that is, because we have a lot of that in our body. So because it is so diverse, it has a lot of different functions. So you can see forms connections, supports our body, builds things in our body, transports things in our body, defends our body against infection. So like I said before, it is very diverse. Well, the functions are very diverse as well. Now, it gets pretty interesting here. When we were talking about epithelial tissue, one thing to note about epithelial tissue is all those cells in epithelial tissue touch each other and form connections with each other. Same with muscle tissue. Nervous tissue is a little bit different. But with connective tissue, we have this stuff called extracellular matrix. So what that means is that the cells are not actually touching each other. So if I have a connective tissue cell, there's going to be a cell, then there's going to be a little bit of space between it, then another cell, a little bit of space between it, then another cell. So the cells of the tissue are not touching each other. So when we talked about simple squamous epithelium, I always pointed out the floor tiles in my room, these flat cells that touch each other and really form these nice, neat structures. With connective tissue, there's this stuff in between the cells. There's gaps, all right? That gap is called extracellular matrix. And that extracellular matrix will really determine the qualities and the characteristics of that tissue. So two really easy examples. Bone. Okay, you have bones in your body. They are made of these cells called osteocytes. Okay, but between the osteocytes, there's this really hard stuff. We'll get into what exactly that is later, but it's mainly this stuff called mineral salts, a lot of calcium. Okay, and that stuff's really hard. So the extracellular matrix of that is really, really hard. Now, blood is a liquid. Now, you have three different types of blood cells. You have red blood cells, white blood cells, and platelets. Well, they're all floating around in their extracellular matrix called plasma. That plasma is a liquid. All right. So the extracellular matrix, the area between the cells, and that's what gives each of these tissues their characteristics. And you can see that that extracellular matrix does some stuff, right? Has some functions. It provides support. It suspends the cells. It helps to keep them safe and nourished and regeneration. So there you go. That's just what I just talked about. They can be rigid and dense, or they can be a fluid. Sometimes, like with fat, they're going to be kind of soft, and we'll see those as we go through the unit. All connective tissue is going to be made up of three types of fibers. You're going to hear me say fibers a lot throughout these videos. Okay, so the first type, and really they're all made of collagen, okay, which is a protein. You see there the major structural protein of the body. So this collagen is going to be kind of put together in different ways to form these fibers. These fibers are going to be produced by cells called fibroblasts. Think of continuous, when you hear the word blast, B-L-A-S-T, a blast cell is a building cell. So think of the B in that word. So a fibroblast is going to produce or build fibers, these connective tissue fibers. An osteoblast will build bone. A chondroblast will build cartilage. So keep that in mind as we go through these. So here we go, the different types of fibers. First type I have is collagenous fibers or white fibers. These are really tough, really strong fibers. This is when I have that collagen in like these really thick bundles. If you were to think of, if you've ever been able to walk across a suspension bridge, which is basically a bridge that's kind of held together by these big long cords. Um, those cords, if you look at them really, really closely, are basically metal that's woven around each other, really fibers of metal that are woven around each other, almost like a rope would be. That's what these collagenous fibers would be, these long fibers that are woven around each other in these really strong bundles. Next type is called reticular fibers. These are made of a special type of collagen named reticulin. These are a little bit more delicate. They're not going to be as thick, and they're going to be in areas where we might not need as much strength as I would use collagenous fibers. Our third type of fiber is known as elastic fibers. Elastic fibers are just like they sound. They're elastic. So if you've ever taken a rubber band and stretched it and then let it go, what happens? It goes back to its original length. That's what elastic fibers can do. Okay, you can stretch them and pull them and twist them and turn them and everything, and they're going to go back to what they originally started as, the same shape, the same length as they originally started as. They're made of a really special protein called elastin, which you can see right here. Now, when you're looking at these things, truthfully, there's not a lot of great pictures and visual aids that I can show you with them. But as we go through the tissue, you'll start to see how they're built, and you'll start to see these fibers pop up within the tissues and what they look like. So again, I have a major protein, this collagen, okay, major protein that really builds a lot of structure in our body. But then all these fibers are made of collagen in one way or another, put together, or maybe a little bit more delicate one way or another. And then the last one, elastic, is made of a special protein called elastin. And those are the fibers that make up connective tissues.